Hey guys, today we're going to look at Volume of Prisms Part 2. In Volume of Prisms Part 1, we looked at volume formulas and we just strictly found the volume of certain prisms. In Part 2, we're going to take some problems where maybe we have the volume and we're going to find some missing parts of the prism, and then we're going to look at some word problems. Alright, so let's do a formula recap here. Rectangular prism, formula for volume is length times width times height. For triangular prisms and other polygonal prisms, volume equals capital B times W, capital B being the area of the base, which in a triangular prism is that triangle. In this hexagonal prism, it's the hexagon, and the pentagonal prism is the pentagon. And times W, which is the distance from one base. So here at the two triangles, this distance right here, or this distance right here, or this distance right here. Some people call that the height of the prism. Our formula sheet uses W for width. Alright, so we want to find the height of this rectangular prism. If the length is 12 feet, so that's our length. The width is 5 feet, that's our width. And the volume is 120 square feet. Alright, so we're always going to start off with writing our formula. Length times width times height. And we're going to substitute numbers in. So I'm going to put 120 in for volume. My length is 12. My width is 5. And then the h, the height, that's what we don't know. All right, so I can multiply that 12 and 5, and I get 60. I still have our h. So here we're just going to solve for h. One-step equation, inverse operations, divide by 60 on both sides. And I get that h equals 2. So I'm going to come over here and write my final answer with a label on it. My height is 2 feet. All right, so we use the volume to find a part of the prism. All right, same idea here. We want to find the width of the triangular prism. That's right here. If the height of the triangle, remember this is the height of the triangle now, 10 meters, and the base of the triangle is 6 meters, and the volume, 360 square meters. Right, so our formula, volume equals big B, area of the base, times the width. For this triangular prism, big B is the area of a triangle, and that formula is 1/2 times the base, little b, of the triangle, times the height of the triangle, and then times the width of the prism. So let's substitute some numbers in. We'll put 360 in for volume. 1/2 times the base of the triangle is 6. The height of the triangle is 10. And then the width, we don't know, that's W. Alright, we can multiply everything in the parentheses. 1/2 times 6 times 10. We get 30. And then we're at a one-step equation. Again, we'll use inverse operations. We'll divide by 30 on both sides. W equals 12. So I'm going to write my answer with a label. W equals 12 meters. And that's our width, 12 meters. All right, now we have a word problem. Here, if the measurements of a ream of paper, and we're talking about this guy right here, 30 centimeters by 20 centimeters by 5 centimeters, and the measurements of the box that they go in, 60 centimeters by 40 centimeters by 50 centimeters, how many reams of paper will fit in the box? All right, so we're going to start off over here with the ream of paper. It's 30 centimeters, 20 centimeters by 5 centimeters. So we'll call that the length, that the width, that the height. Volume equals length times width times height. So what we were basically doing is finding the volume of that, finding the volume of that, and since we want to find out how many of these fit in there, we're going to take the big volume and divide it by the little volume. So here, length 30 times width 20 times height 5. 30 times 20 times 5, 3,000. And that's 3,000 centimeters squared. All right, now we'll use the box, and that was 60 centimeters by 40 centimeters by 50 centimeters. So once again, this will be our length, this will be our width, this will be our height. Volume equals length times width times height. This is obviously going to be a much bigger number. 60 times 40 times 50. Multiply all that together, we get 120,000. So that's a volume of 120,000 centimeters cubed. I think I said squared over here, that's cubed. Alright, now we need to take these two numbers, and we'll take the volume of this, 120,000. We're going to divide it by this volume, 3,000. Cancel those zeros out. And then 120 divided by 3 is 40. So that means I can fit 40 reams of paper in that box. There we go. Alright, last one. If a man is shoveling dirt into the prism shown below at a rate of 1.5 cubic feet per minute, how long will it take to fill the prism? Alright, we're talking about filling that prism, how much space that prism occupies, so we are obviously talking about a volume problem. So volume equals area of the base times the width. In this example, the area of the base is 6, the width is 3. 6 times 3 is 18, so our volume is 18 feet cubed. Alright, so this pentagonal prism has a volume of 18 cubic feet, and this man is shoveling 1.5 cubic feet per minute. So to figure out how long it's going to take, I'm going to take the 18 and I'm going to divide it by 1.5, and I get 12. So it's going to take 12 minutes. Alright, that's Volume of Prisms Part 2. Good luck, guys.